There we go. All right, everyone can still hear me? Okay, so first I'm going to tackle 99 bottles in Python. So I'm going to navigate into that directory, and I'm going to, what was I going to do? I'm going to open up 99 bottles. There we are. All right, so how did people find this one compared to doing it in JavaScript? Yeah, easier? Yeah, and some of that could be because, you know, you've done it before, of course, so the logic is all there. It's just translating to a new language, right? Yep, so let's just kind of go over it real quick. So there's many different ways to do this. So I'm going to, well, what are the two ways we can handle this? Because we have 99 bottles that we need to take off of the wall, right? And there are two ways to get from 99 to 0. Does anyone tell me one of them?
Would be a while loop, while x is smaller than input.
Yeah, exactly. A while loop is one of them. And that's an example of, we talk about two words. One of them starts with an I, one of them starts with an R.
Iteration and recursion.
Iteration and recursion, thank you. Yeah, so iteration and recursion. So that's the iterative method, is doing a while loop. We could also use the recursive method. Which one would people like to see here?
Recursive is more difficult.
Yeah, let's see a recursive method. All right, in order to do a recursive method in that case, we're going to have to make sure that our bottle song method takes a number as an argument. So I'm going to do that, put num there. And make sure that when we pass it in the first time, we're going to give it 99. All right, so now I'm going to have to be able to use, there's a few ways I could do this. I'm going to check to see what to do if there's more than 1 or 2 bottles, right? So we could say, if the number of bottles is greater than 2, we could say, using an F string, we can interpolate. We could say num, bottles of beer on the wall, num, bottles of beer. Get another F string going, take one down, pass it around. Num minus 1 bottles of beer on the wall. All right, and then what do we have to do? So if we want this to be a recursive method, let's say, Beck, how would we make sure that turn this into a recursive method? What does it need to do?
It needs to have a base condition, and it needs to have a call to itself.
Yes, exactly. So to make a recursive method, you need to have a base case, and you need to be able to call it when it's not hitting the base case. What happens if we don't have a base case?
It runs forever.
It runs forever. And it's actually more dangerous to have a recursive function that goes forever than an iterative function that goes forever. An iterative function will stop once it runs out of memory. A recursive function might actually crash your CPU. So we're kind of playing with fire here. So knowing that, let's get our base case first.
Could you please elaborate on how it stops when it runs out of memory and versus crashing CPU? What does that mean, crashing CPU?
So there's a limited amount of memory that your computer has. And every time you run a program, it uses up some of that. And when you iterate, there's kind of built-in stoppers that you've made that'll just say, if you're hitting an internal loop, it'll just say, okay, we've used up enough memory. This is clearly not going to stop going. It'll shut it down. A recursive function, since calling the function again and again and again, there's no iteration there. It doesn't really have that in check, so it'll just keep on eating up memory until
the operating system?
Yeah, okay. Pretty much. Is that a hand raise?
Do we use 2 separate print statements to make it easier to snap read the code instead of having it all on one
Yeah,
same line?
that's a stylistic choice on my part, because I could also do, you know,
I didn't know if there was a best practice.
Yeah. I could put a new line character and then do take one down, pass it around. But this, putting it on 2 lines makes it more readable.
Right.
I also realized that that would have to go there, not outside the quotes. So that's just a choice on my part, because every time you print, it automatically starts a new line anyway.
Right.
So it just feels easier to read. All right, so in this case, let's get since we don't want to crash my computer, let's get our base case set up. What's our base case for this particular thing? When should it stop running the function?
When it hits 0.
When it hits 0, we could go until it hits 0, but we also know that the last 2 lines of the song, last 2 verses of the song have their own special syntax to them, right? So in that case, we could say, all right, the last 2 lines of the song, verses of the song are always going to be the same. So we could just hard code that in and then just have it print out normally. So I kind of already set it up a little bit by saying if num is greater than 2, do this. And then I'm going to put an else here. So yeah, so we could do elif. Yeah, so elif. We could do elif and say if num is less than or equal to 2. And that would still work. But in this case, it's more or less the same thing as else, because we're starting at 99, we're counting down, and we're saying, okay, if number is greater than 2, do this. Is there anything, what other things can happen besides the number being in 2, greater than 2? What's the alternative to the number being greater than 2? Yeah. In this case, the else just says, okay, if it's greater than 2, do this. If it's anything else, which means 2 or less, do that. So we could be explicit about what condition we're looking for. But if there's only one possible other condition, then else does the job just fine. Good question. So I'm going to just do the last 2 lines of the song here. Two bottles of beer on wall, 2 bottles of beer. Take one down, pass it around. 1 bottle of beer on the wall. Just kind of copy these, perhaps. Make sure that's bottle of beer, not bottles of beer. Pass around, pass around. No more bottles of beer on the wall. And I'm going to leave the last 2 lines of the song for later. I just don't feel like it right now, because that's not really important to what we're trying to learn. So up here, back in our kind of the recursive statement. So we know we need to make a function call in order for it to call on this recursively, right? So we can just say bottle song. What is it going to be taking as a argument in this case? Yeah, number -1. So we print it out, we give it another function, we give it an argument that is smaller than the one before, and it'll keep on doing that until it hits our base case, which is the number being less than or equal to 2. So if I run this now, we should see all right, that looks pretty good. We can also try it again with a smaller number just to make sure we don't have to see everything. Whoops. There we go. So we have 10 bottles of beer on the wall, 10 bottles of beer, take one down, pass around, 9 bottles of beer on the wall. And then, again, if I wanted to, we could also, put in the last 2 lines of the song, but at this point, it's, you get the idea. It's a pretty simple song as songs go. All right, what questions do y'all have about recursion and 99 bottles in Python?
You said, or somebody else in this question said that the recursive function takes in two things that are base case and what?
So I'm not. I'm sorry. I'm not sure what you mean.
Oh, no, it's fine. Somebody said that the function takes base case and something else. And what's that something else?
So a base case, and then the function has to return itself.
Okay.
Until that base case is met.
Oh yeah, right.
The return.
Yes. Thank you for reminding me that. I believe. Yeah. So with Python, so with JavaScript, we can keep on doing that. Because this function doesn't have a return value, it's just printing lines to the screen. It's fine. But normally you would want to say return the function call. And if you don't do that, the function will return nil even when it gets to the base case. Because you're not actually, the original function isn't returning anything. So yeah, that's a kind of a big mistake on my part. If I wanted to return something, it would just return none. And I would be stumped for a while about why that was happening. So yeah, make sure you write that down. When you're recursing in Python, you got to return your function call.
So we got to do this both in Python and JavaScript. We got to return something when we try to do recursive.
We'll go over recursion specifically next week or something, but yeah, we'll really get.
Any other questions about 99 bottles or the recursion? Keeping in mind we're going to have a more detailed recursion thing later. Okay. In that case, I'm going to move on to a new challenge. Let's do Roman numerals. All right, so I'm going to be solving Roman numerals in Python. So there we go. So when we were solving it in JavaScript, we made use of you all probably made use of something to keep track of what the numerals are and what they can convert into for Arabic numbers, right? What were those?
Technically, it was an object.
Exactly. So in JavaScript, we call it an object. In Python, we call it a dictionary. In Ruby, you'd call it a hash. It's got a million different names, but it all operates more or less the same way. We've got the curly brackets, then we've got key value pairs. So I'm going to set up some key value pairs in Python. So we can call it numerals. All right. Now, how did people structure their numerals when they did this? Hey, someone from the remote side this time. How did you all set up your data structure for this?
I used two arrays. I didn't set up a dictionary like this.
Just do a dictionary in descending order from greatest to smallest.
Okay, cool. So I heard a dictionary descending from greatest to smallest. I also heard two arrays. So that would actually work as well, because the cool thing about arrays is they always have the same indexes, provided the same length. So as long as the index numbers match up with each other, that would work just as well as a dictionary would in this case.
For like regular dictionaries, they're unordered, so we have to use the ordered dict function, or
so we could use the ordered dict function. You can also loop over just the keys or just the values of a dictionary in terms of an array. So there's a lot of different ways to do this. And you know what? Thinking about, before we actually get into that, thinking about what we were doing with John yesterday, maybe we should do some pseudocoding first. Okay, so we know we need to set up some kind of data structure, right? Yes.
So we didn't use a data structure at all. We just did if-else statements for the entire thing, and everything worked out. Is that like monumentally inefficient?
you take the switch statement.
Yeah, kind of. Well, I mean, in this case, for Python, we didn't know how to do the switch statement, so it's just if-else.
Yeah, I mean, it's
Is it just because
in terms of
so few data points it didn't matter, or?
yeah, in terms of like efficiency, probably work out to be about the same. In terms of lines of code, That's a little more that work that you need to do. So, so it definitely, if it works, it works.
Okay.
But using data structures can save you a lot of time when it comes to things like that. So I'm going to say set up some kind of data structure to hold numerals and numbers. All right. Once we have that data structure in place, what's the next step? Taking it as granularly as possible. We've got our number, we've got our conversion kind of table. What's next?
Create a function that takes in the data structure as an input.
Yep. So
as one of the inputs.
Yep. Are we getting? Oh, we're getting chat things. Okay, we want to put that over there. So we need a function that'll use that and take an input. So, and luckily that's been kind of done for us already, but I'll still do that. Create a function, uses the data structure, and takes in an integer as an argument. Okay, then what?
Want to loop through the dictionary?
Loop through the dictionary. Okay. So loop through the dictionary. And what are we doing on each iteration of this loop?
Finding the highest number that we can remove out, right?
So find the highest number, but you can remove out. Could you elaborate on that a little bit?
So we would want to get rid of the thousands first.
Yeah.
And then the 900.
All right, so putting that into more kind of computery logic, we could say, if what? We want
Divide, then you get the greater than 0, and we keep doing.
so if our number is smaller than where we are in the dictionary. Okay, so if the number is smaller than where we are in the dictionary, if that is, what do we want to do?
Reduce the argument value by that dictionary value.
Reduce the number by the dictionary value. And what else?
Add its key to the string, to a blank string.
So add
To the string.
add the numeral, the Roman numeral,
Yeah. I don't have the dictionary set up.
to the string. We haven't actually, and I know John would want to do it this way too, the string. Have we defined a string at this point?
No, we have creates blanks. So creates
So
empty string.
define an empty string. Add the numeral to the string, cool. And then what do we do after that?
Assign the remaining value of the remainder to the number, so that we loop through it again.
Yeah, you basically do the same thing with the remainder.
So you're using division and modulo, is that it?
Yeah.
Okay, cool. And so we already have something that says reduce the number by the dictionary value.
Okay, so the remaining value, what we have left, we assign it to the number, go over it again.
Yeah. So I think that's kind of like those are different processes of doing the same thing, I think, right? All right, and then once we're through our loop, what's the last thing to do?
Print a string.
Yeah. In this case, we're going to return the string. Okay. Cool. So there's two ways of handling this, either two arrays or two dictionaries. I'm going to do I'm going to do a dictionary because I like dictionaries. So I'm going to call this one numerals. And we're going to do that in descending order, like I heard people say. So let me look up the actual guide here, Roman numerals, so I can actually, I don't remember what it is. All right, so it's M, D, C, L, X, V, I. Okay. So M is 1,000. Now, if we're doing the true Roman numerals, not the lazy Roman numerals, then in that case we want to include also things like 900, 400, and things like that, right? Just gonna check the chat real quick. I was just like taking a look at making sure I didn't miss anything. Any questions in the chat? All right. So M is 1,000, and then
We'll speak up if we have questions. We're kind of
okay. Thank you.
sidebar, sorry.
All right. So then I believe CM is 900, and then 500 was D. Thank you. There I am. Sometimes lose track of the cursor. Also, that should be a colon, not a comma. There we go. Then L is 50, right?
Yep.
So XL would be 40. I always remember that because Super Bowl 40 was in my hometown, and and remember Michigan was leading the country in obesity at the time. So it was like, ah, yes, Super Bowl XL, that's us. There we go. All right, how's that looking? Am I missing anything there? Awesome. Okay, so now we want to loop through this dictionary. Now, there's a few ways to do this, right? So if we're talking about looping through a dictionary versus, say, looping through an array, like what are the big differences between a dictionary and an array in terms of how they're set up?
Dictionaries have keys and values.
Yes, they do. And an array is what?
Indexes.
Indexes, meaning that an array is always ordered a certain way. Everything shows up as 0, 1, 2, 3, so on and so forth ad infinitum. But a dictionary, technically speaking, isn't set up in order. Like, it looks like this because that's how we wrote it on the page, but these key value pairs don't necessarily live there in that order. The key is exactly what keeps it the way it is. So we need a way of looping through this to make sure we're doing it in the proper order, right? So we sort it. So how do we do that? Let's find out. So I do Python dictionary methods. W3 Schools is a great Python reference. So here's what Python has built in available to us for dictionaries. So we have a thing called clear, no, copy, from keys, return a dictionary with the specified keys and values. Not quite. We don't want to get something because we want to see everything. We do have something that says return a list containing the dictionary's keys, and we also have one that says turning its values. I think this is the one we're going to want because in this case, we're what keys does. Let's take a look at the documentation here. So they have an example of a car which has a brand, a model, a year. And when you call x.keys, let's take a look at their example. X.keys returns an array with just this part. If we have the keys in an order, and in this case, keys puts it in the order that it's written, that means we can have access to everything, right? We have the keys to the kingdom. Thank you, thank you. I'll be here all week. Let's see if there's any other way to loop through a dictionary as well, because there may be other ones. If I do Python dictionary loop. How to read through a dictionary in Python. I love it when it's so explicit like that. So you can iterate through the keys directly. Like there's a table of contents. This is a good blog post. So dictionaries are mapping objects. This means they inherit some special methods. Visualize that. They have this thing here for mapping like dictionaries. So they have, so we could do for key in a dict. So we don't even need to call on .keys, it looks like. They have a for loop that says for key in a dict. Let's test that out. So I could just say for key in numerals. Print key. Let's see what happens. Do we have a function call? All right, so that was 2 Roman. Just give it 54, random number. Whoops. Let's try that again. Oh, got to get into the Python directory. Okay, we have all our keys. All right, so that's another step down. We created a function. We kind of skipped defining an empty string again. That's my bad. But we have our loop through the dictionary set up. It's ready to go. We have a loop that can go through all of our keys. So let's define that empty string. Okay, we have an empty string. We loop through the dictionary. Now we need to check if the number is smaller than where we are in the dictionary. So we have if num is less than, and how can we check where we are in the dictionary? If we're starting at the 1,000, right? We have it. So what variable do we have to help us, variables, I should say, that help us figure that out? Yeah, key. Yeah. Yep. So it's less than or equal to numerals key. So if that happens, what do whoa. Okay, I'm just gonna ignore that and pretend nothing is wrong. All right, so if the number is less than or equal to numerals key, what do we do? Yeah, say num minus equals. All right, that's one step of our pseudocode done. And then we want to add the numeral to the string. And in this case, the numeral is what variable? Key. The numeral is the key. You could say. All right. So we keep on doing that. We loop through it, add the numeral to the string, return the string. Okay. So that's all our pseudocode done, right? So how does this look to everybody?
Efficient.
All right, let's test it out a little bit. Let's hear. Do we have a spec file for this? We do. So we have some basic tests. Print Roman numerals spec. Oops, Python. What the heck am I thinking? Uh-oh. All right, false, false, false. Not great. Should probably figure out what did we actually get if we didn't get this? Whoa. Okay, so we're way off. All right, let's take a look at what actually happens. So we have our numerals. That all looks in order. We have our answer string for key numerals. If num is less than or equal to numerals key. Anyone seeing what I did wrong there?
Yeah, you're just instead of no.
Probably should be greater than.
Should be greater than. Very simple error. Okay, so it was literally adding everything. Okay. So, Okay, so that's closer, but still not quite right. If I look at this, so it got 1 correct. When it got 3, it just put I. When it got 4, it put IV.
So we are just we are not repeating it if it's like divisible 3 times.
Yes, exactly. Well spotted. So our iteration is saying, okay, we have a for loop going on that checks each key in turn. And then once it checks the key, it says, okay, is this greater than or equal to this number? If it is, subtract it, add the key to our string, but then it moves on to the next key, which is fine if we have 1 or 4 because those are already just the key themselves. But if it's like 3, I want it to stay adding i's until there are no more to add. So there's another step we missed. So let's pseudocode that in right here. So reduce number. So if the number is smaller than where we are in the dictionary, reduce the number of the dictionary value. So let's rephrase this a bit. We don't want to do this just once, right? So what can we use to make sure it keeps on going until it's ready to move on?
While.
Yeah. So we can say instead of if the number is smaller, while the number is larger than where we are in the dictionary. So in that case, we don't even have to change much. We can literally just change if to while, which is nice. So I love when fixes are that simple. So now it should keep on doing that until it can't do that anymore. We'll try that out. All right, that's our first 3 tests passing. Let's try a few more just to make sure that we're not missing anything with a bigger number. So first I'm going to put this back into kind of a more spec form. So let's say, try one with
1738.
1738, like the number? Okay. What do we expect that to be in Roman numerals? I believe that would be, let's hear, M. If you look at our Roman numerals, then we have a 500, so MDCC. CC, and then 30 would be XXX, VIII. Easy to remember, right?
Let's try 944 for 1.
So what was it? Sorry?
944.
944? Oops, this should be 944. So 944 in that case.
CMX LIV.
Says cheater.
Well, you know, being able to translate to Roman numerals in your head is a very important skill nowadays, isn't it?
It is. It is.
All right, and let's do one more. Like,
8, 6, 7, 5.
no, I'm not doing that. Let's just try like a smaller one, like just 23. XXII. So hopefully we should see just 6 trues flash across the screen. True, 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 true. Great. So it looks like we have a working solution for Roman numerals in Python now. So first off, I just want to say, let me know if I'm going too fast. I do have a tendency to rush ahead, I know. So if I'm zooming ahead and you'd like slow down, just let me know. But pause for a bit and say, ask what questions you have about this particular solution.
Yeah, no?
Yeah?
Yeah, I had a question. So the way I did it, I didn't use 2 loops just because of the efficiency. So could you show us a way to do it just using 1 loop? If we got time.
Let's hear it. I'm sure that's possible, but actually I'd have to think about that for a bit because this is the solution that I've always used. So I have to think about that. So you said you did a solution with just 1 loop, right?
Correct.
Okay, could you walk us through that? Or actually, even we could probably look it up on GitHub, I bet.
I didn't use a dictionary in mine. I copied kind of Brian's to arrays type thing, but did it with 1 loop.
All right, did you do a pull request?
Yes, it's at the bottom.
This one?
Yes.
Cool. So let's take a look. So we should be able to say, all right. So, yep, I see your two loops. Cool. Could you please like keep on talking me through it, because like I'm curious. I'd like to hear it. So you have two loops.
No, one loop, but I used two arrays.
That's what I meant.
I guess we could combine it into a dictionary.
Okay, but all right. So we have those, and then what do you have here with this for loop?
So for the for loop, push is the variable that determines how many times that it will actually push something, and it's using math floor. It rounds to the nearest to the bottom of it. So if it's like 3.33, it'll just be 3, right?
Mm-hmm.
Then you could just push it the Roman character X amount of times, and then store it, and then just minus the number after that.
Okay. Yeah.
I don't know. Kind of makes sense in my head, but I think kind of differently than other people.
I
So
know.
the push essentially just gets rid of the while.
Mm-hmm.
That's all.
Yeah, so this involves a little more algorithmic thinking and mathematical thinking. I'll be honest, like when I was considering this solution, I never thought about trying to determine the actual number via a mathematical formula. That wouldn't have occurred to me, but that's cool. That means that you're thinking in ways that I'm not, and that's important because that's the best part of working in like pairs and working in group projects is you get a lot of perspectives and many different people talking about how they want to best handle something. That's really good. This is also definitely a very elegant and viable solution. I'm not sure if it's necessarily more. It is more efficient. I'm not sure how much more efficient, but in this case, because it's a relatively small loop, but for much larger numbers, this would probably go much faster.
Right. And the one aspect that would deter me from using two separate arrays is that if I somehow made a mistake and messed up the index to where they match up, that's one of the, I would say, one reason why I wouldn't use two arrays. However, utilizing one for loop is obviously a lot more efficient than using two for loops. From like an O(n) perspective, this is definitely more efficient time complexity.
Yeah.
Right. I think next time I'm just going to use a dictionary instead of two lists. I didn't even think about using a dictionary, honestly. Just kind of went with it.
Yeah. And in this case, your for loop structure wouldn't have to change if you're using a dictionary. You just change how your index, your for loop would be set up a little bit differently in terms of just how you wrote it, but it would still work the same way. So yeah, good work. Cool. Any other questions about Roman numerals?
I have a quick question. Since we're like talking about time complexity, is there documentation like that actually tells you what like the big O is for like math.4 and all that stuff for all these methods? I'm just trying to look it up.
I don't know any specific documentation that states what the time complexity of built-in methods are. I think they depend on the language you're writing in. So Ruby might be different than, like, they're all dependent. They all, under the hood, they operate a little bit differently. So
Yeah, I was just wondering if there was, like, if Python had a library like that told you that, or if it was in the documentation somewhere.
Yeah, not sure.
I'll keep searching.
But one thing I might send out to Slack later is I have a very good, I found a very good video for explaining BitGo and how to calculate it in general terms. So I might send that out later.
if you don't know what BitGo is, if you're like, what the hell are you guys talking about? Don't worry about it. We'll discover it later.
Yeah. Okay, great. Any other questions?
Can I see that 99 bottles again real quick?
I'm sorry, could you repeat that?
Do you mind? Can you just pop up 99 bottles real quick? So I
Yeah,
can look at it again.
let's see, do I still have that? No, I'd have to. Yeah. And also just talking about this particular solution, I wouldn't necessarily go with the solution as like a general thing of more of better necessarily. I just wanted to kind of show off different ways of doing it. An iterative solution to this would probably be preferable, at least to my thinking. And usually iteration is more efficient than recursion. But this is a very good this is a real good project for practicing recursion on as well.
Thank you.
No problem. All right, so in that case, I think we'll take a break here, 10-minute break maybe. Let's come back at 8:54.